Okay, so in part A of P5 is all rational expressions, so we're going to continue with that stuff. But part A was just simplifying the rational expressions. So we wanted to look and see if at this point we could reduce the numerator and the denominator by dividing dividing the same term into both the top and the bottom. And then on some of these, we have to factor first to determine if that's right. So for number 1, we didn't have to factor first. We just have to look at the two terms that are there. So if I have 18y squared and 60y to the third, what go into, let's start with the number part. What goes into 18 and 60? 6. So this would be 3, and this would be 10. And then I have 2 y's in the top and 3 in the bottom, so I can cancel through 2 of those, leaving you with 10y in the denominator. Then I go to 2, and now I've got to factor that one first, right? So I'm going to factor the numerator first. The x is at the end, and it's negative, which means one's going to be a positive x, one's going to be a negative x. And then the beginning goes the factors of 15, so that when I did outer and inner, I get positive 2. So 15 could be 1 and 15, but it could also be 3 and 5. If I multiply the outer and the inner here, I get negative 3x and positive 5x, which gives me the positive 2x. So I know that's the right combination. The denominator, so I'll do first and last here, so we practice that. If I multiply first times last, 2 times 3 is 6. Factors of 6 that sum to 7 would be 1 and 6. Replace that middle term with 1x and 6x, and then the 3 goes at the end. Factor by grouping here. Take out an x from the first set of parentheses. Take out a 3 from the second set of parentheses, and I get 2x plus 1. And then x plus 3. So that's my denominator, 2x plus 1, x plus 3. And then from both my numerator and my denominator, I have an x plus 3. One's 3 plus x, one's x plus 3, but remember, addition doesn't matter the order. So those get canceled through, and my overall answer here would be 5 minus x over 2x plus 1.
So every time you have a question where the x is at the end of the original problem, do you have to do outer and inner?
I mean, you don't have to unless if it was positive, I wouldn't worry about it. But because it's negative, that's where I have to worry about it.
Okay, so I think that answers my question for the homework.
Okay, perfect.
Thank you.
You're welcome. Okay, now, go ahead.
The x was positive.
Then I'm just looking for the factors of 15 that sum to 2, which wouldn't work, obviously, because it has to be negative. But if it was like the factors of 15, the middle term was 16, then I just used 1 and 16. I don't have to worry about the signs.
But you put the number, then the x?
Yes.
Okay.
All right.
I'm getting like negative 5 plus x over 2x plus 1. Does that count too?
Negative 5 plus x over 2x plus 1, your signs are off. So there shouldn't be a negative on the 5. The negative should be on the x.
Okay, because for the top one, instead of like, not factoring, instead of the trial and error, I did the multiplying thing.
Okay, so then you should have gotten 15 times negative 1, right? So 15 times negative 1 would be negative 15. Factors of negative 15 that sum to positive 2 would be a positive 5 and a negative 3. Plug.
Which shows I did negative 3.
There you go.
5.
Yeah, because the process should be the same. Like it should give you the same answer. So you had to have made a mistake somewhere along the line to get. So it would have been 3 plus.
Right. I was thinking it's a negative 2 because I thought it was a positive 2.
I got you.
Okay.
Now it's the same, right?
Mm-hmm.
Yeah. Okay. All right. Then number 3. So number 3 had the difference of 2 squares in the top. I'm going to factor that by doing x plus 5, x minus 5. The denominators factor by grouping. So I'm going to group these and these. I take out the x squared, x plus 5. Take out a positive 1, x plus 5. And I get x plus 5 and x squared plus 1. That's the denominator. And then I can cross through the x plus 5s, and I get x minus 5 over x squared plus 1. Questions on those? All right, so Juliana, this one was yours. So you understand now that this would have, you had to do the x at the end, right?
Yes.
Yeah, okay, perfect. You're welcome. Okay, then the error one. So this said describe the error, right? This is like totally open-ended, so it can't really grade it perfectly, so don't stress if you got it wrong. I would have given you the credit on that answer, Kat, so don't worry if that's what it is. If this was a question on a test and you had written that, I would have given credit for the answer. You cannot cancel just part of your expression. All right. P5 part B is multiplying and dividing rational expressions. So we kind of take this one and then 2 steps further. You're still factoring, so I want to stress that that's not going away anytime soon. We're going to do it for several sections to come, and then you'll see it sporadically throughout the year. But you are going to now multiply 2, which means you're going to have 4 parts to factor, or divide 2. So when you're multiplying the rational expressions, you're going to factor each part of the fraction. So if I've got something in the top here, over here, times whatever this is, over this one. Not necessarily factoring all 4 parts every time, because some of them won't be factorable. But if they are factorable, you're going to have to factor this part, this part, this part, this part. And then you can cancel the numerator and the denominator, either top to bottom or cross cancel. So if there's something over here that cancels with something over here, I can cross cancel. If there was something in the numerator that cancels with something in the denominator on a single fraction, obviously I can simplify that. That's what we were doing yesterday. That's going to be multiplying. Then comes dividing. So that we're going to keep, change, flip, or stay, change, flip, then factor, then cross cancel or cancel top to bottom. Okay, so this says simplify, and we start with number 1. Number 1 says, zoom in on that, x minus 2 over x plus 3 times x squared minus 9 plus 4. So what I want to do is look at this in each part, look and see, can it be factored? So is there something I can do with x minus 2? No. X plus 3? No. X squared plus 9? What's that called?
Yes.
Good.
Difference of squares.
Difference 2 squares. This becomes x plus 3 and x minus 3. So now the x squared minus 9 is gone. And then x plus 4, again, can't do anything with. So I can cancel top to bottom. If there was something on just this side, I could cancel top to bottom like we did yesterday. I would, but there's not. The other option I have is a cross. So if I look at x minus 2 and x plus 4, there's nothing to cancel from there. But if I look at x plus 3 and then x plus 3 and x minus 3, I can cancel out the x plus 3s. Now look at what's left in my numerator. So come straight across here, and I have x minus 2 times x minus 3. The denominator, I just have x plus 4. And you will leave it like this. So don't then FOIL out x minus 2 and x minus 3. Okay? You want it as simplified as possible, which is this. Questions so far? Okay, number 2. So there's that x minus 9 again. This time it's in the top left. X plus 3, x squared minus 9, sorry. X minus 3, so now this is gone. The top right, bottom left can't get simplified. The x plus 3 and the x minus 3 this time. And the x minus 3 get canceled. And look at the top and the bottom on the left-hand side. There's an x plus 3 and an x plus 3. So this time, the only thing left in the numerator is x plus 4, and there's nothing left in the denominator, which would be technically over 1. But you don't need to keep an over 1. It's just x plus 4.
If the x squared minus 9 was in the denominator, would you be able to, like, FOIL it out?
You can still factor it no matter where it is. If these were switched, or if...
Yeah, because I don't know, for some reason I thought that if it was like a negative, you couldn't. I don't know why.
Yeah, no, if it's x squared minus 9, that's different to 2 squares. If it was x squared plus 9, then I can't factor it, right? Because it's not the difference.
Okay.
Is that what you mean?
Yeah. That's
Yeah,
what I meant.
okay. The location of where it is doesn't matter. It just depends on if it's prime or if it's factorable.
What was the answer for the first one again?
X
Oh,
minus,
okay.
there you go. Okay, More examples, obviously just getting more complicated. So number 3, there's 4 parts that are going to get factored. I'm going to factor each, yay. We're going to factor each individual part, okay? So if I look at the top part here, I'm going to color code them so that we can kind of separate them out. This, I'm going to do, because we did the first and last, I'm going to do trial and error this time. There's a factor on the front. It's not a perfect square, so it's not a perfect square trinomial, which means I have to do 2x and x. And then the factors of -6, which would be 1 and -6, -1 and 6, 2 and -3, -2 and 3. So if I did +1, -6, that's going to be -12 plus 1. Way too big. Same thing's going to give me the same number, just a different sign if I switch the 1 and the 6. So let's try the 2 and the 3. This would be -6x plus 2x. That doesn't work. Switch the numbers, not the signs, but the numbers. 3 and 2. Now I get -4x plus 3x, which is a -x. I have the right numbers, wrong sign. So I switch the signs. Now I've got +4x, -3x, and that gives me the +x. So the top left, I'm going to rewrite it underneath, is now this. 2x minus 3 times x plus 2. I'm going to go to bottom left. This one's a little bit easier. There's no term on the front. Factors of -5 that sum to +4 would be +5 and -1. That goes in the bottom. I'm going to go to the top right. Here I can take out an x, and I get x squared minus 3x plus 2. Is that as factored as it gets? Are there factors of +2 that sum to -3?
-2 and -3?
Good. X minus 2, x minus 1. So that takes over the numerator of the right side. And then denominator. Does the same color? Yeah, I'm going to do a different color. Take out up 2x, and I get 2x minus 3. Nothing else can be factored from that, so that becomes my denominator. This is multiplication. Okay, so now remember, I can cancel top to bottom or diagonally across. What do you see that you can cancel?
X minus 1.
The x minus 1 from here and here.
The 2x minus 3.
The 2x minus 3 from here and here. Anything else? Look, there's an x and an x. So now the numerator, I have x plus 2, x minus 2. The denominator, I have x plus 5, 2. So when I rewrite this answer, it's x plus 2, x minus 2 over 2 times x plus 5. Questions on that one? So that's pretty much like as complicated as they get with multiplication. You could have to factor all 4 parts. If nothing cancels, I would go back and check your factoring, right? Because usually things are going to cancel. Okay, the last one's a little bit easier, right? So now, and there nothing is factorable. It's already factored. The 5 is going to cancel into the 25 and give me 5. And the x minus 1 and the x minus 1 are going to cancel. Now there's nothing left in the top. Does that mean I put a 0 at the top?
No, a 1.
Good. A 1 goes in the top. In the bottom is the 5 and the x minus 2. And it's left just like that. Questions on that? All right, you try 5, and then we'll start with the division. So go ahead and try 5, see how far you can get on your own. I have faith in you. All right, so how do we factor the top left?
X minus 3 and X plus 2.
Good. X minus 3, X plus 2. Thank you, Taji. How do we factor the bottom left?
X plus 3, X plus 3.
Good. X plus 3, X plus 3. Top right can't be factorable, right? That one's already done. How about bottom right?
X plus 2, X minus 2.
Good. All right, now we cancel top to bottom. So we see if on the left we can cancel anything top to bottom. There's an X minus 3 in the top and X plus 3 in the bottom. I cannot cancel those, right? It has to have the same sign. The right, I can't cancel anything top to bottom. But I can do the X plus 2 here, the X plus 2 here. And I can do an X plus 3 here and an X plus 3 here. Now, I'm a nerd, but I get excited when I start to cross through the stuff. Like, that's the fun part of this. Like, woohoo, start canceling things out because it means you have to write less at the end. In the numerator, the only thing left is the X minus 3. And in the denominator, I've got X plus 3 and X minus 2. Remember that the plus and the minus cannot be canceled out. If it was X plus 3 in the top, or X minus 3 in the top, sorry, and 3 minus X in the bottom, those are opposites. I can cancel it, give it a -1. But if one's a plus and one's a minus, I cannot cancel them out. Everybody good so far? Yes. Okay. All right. Now we get to division. So before I factor this, and it really doesn't matter what order you do it, if you do the keep, change, flip, or then factor, or factor, then keep, change, flip. I wait until after I flip it just because it will be less to rewrite when you flip it, but it doesn't matter which one you do. So first thing I'm going to do is keep the first one. So that one stays the same, keep or stay. Change my sign to multiplication. And then flip the second one, x cubed plus 3 over x squared plus 2x plus 4. Okay, now I have 4 things I have to factor. Because the top left is a perfect cube. So remember, we cube root the first term, we cube root the second term. The first set of parentheses gets exactly that, x and 2. Second set of parentheses, square the first term, multiply the 2 together, square the second term. And the signs go SOAP. Same, which is minus, opposite, which is plus, positive, which is plus. Bottom left, x plus 2, x minus 2, difference of 2 squares. Top right, perfect cube again, same numbers, x and 2. This time it's x 2, x squared, 2x, 4. And the signs go same, opposite, positive. Last one on the bottom right. Can I factor x squared plus 2x plus 4?
No.
No, there are no factors of 4 that sum to 2. Now comes the canceling, the fun part, right? So I'm going to multiply, or I'm going to cancel from top to bottom or diagonally. If I look at the left side of this, I have an x minus 2 and an x minus 2. I can cancel those. I look at the right side, I have an x plus 2 and an x squared minus 2x plus 4. Close, but not the same as the denominator. So I can't go top to bottom on the right. But I have an x plus 2 here and an x plus 2 here. And my denominator, x plus 2x plus 4, cancels with the numerator over here, x squared plus 2x plus 4. Now look straight across at my numerator. All I've got left is x squared minus 2x plus 4. Denominator, nothing left. Go ahead, Madison.
How did the whole like top part get canceled out,
So this canceled with this.
right?
This canceled with this.
Oh, okay, I didn't see that one.
Okay, and then the x plus 2 and the x plus 2.
Right.
Can you go back up to 5?
Sure. Oh, wait. I don't want to move that one. Hang on. Where'd the work for 5 go? Hang on, I lost it. All the way up there.
How come you couldn't cancel out like the x plus 3 like diagonally?
Hang on, let me pull this down here. Oh my word, work with me here. There we go. How come, say that again, you couldn't cancel out which one?
Like the x plus 3 and then the x plus 3 like diagonally.
You could, but there was 2 x plus 3s. So we did cancel this one with this one, but there was still a second one here.
Oh.
Does that make sense?
Oh yeah.
Okay.
Thank you.
You're welcome.
What ended up being the
Okay, last set of examples, right? So number 7, first thing I'm going to do is rewrite it. So keep, change, flip. Be careful in the rewrite because if you rewrite it wrong, obviously the rest of it's wrong. So x to the third minus 1 over x squared minus 1 times x squared plus 2x plus 1 over x squared plus x plus 1. Keep, change, flip. Then factor. Difference of perfect cubes on the left. This would be x, this would be 1. So I'd get x and 1, x squared, x, because 1 times x would be x, and 1 squared, which is 1. Same, opposite, positive. Bottom left, difference of 2 squares, x plus 1, x minus 1. Top right, factors of 1 that sum to 2, x plus 1 and x plus 1. Bottom right, can't be factored. No factors of 1 sum to 1. So now we cross cancel. Or top to bottom. X minus 1 cancels with the x minus 1 top to bottom there. X plus 1 cancels x plus 1 top right, bottom left. There's still another x plus 1 there, but there's nothing to cancel with. And then top left, bottom right cancels. And all that's left is my x plus 1 that's in my numerator. Questions on that one? Okay, number 8. Little bit simpler. Keep, change, flip. Top to bottom, or left side, nothing to factor. Right side becomes x plus 1, x minus 1. In the numerator, nothing to factor in the bottom. So that's it. I only had to factor one part. We got lucky. There's an x here that cancels with one of the x's on the right-hand side. And there's an x minus 1 here and an x minus 1 here. All that's left is the x plus 1 in the numerator.
What about the other x on the bottom?
Aw, thank you. Over x. Good job.
Wait, I missed it. How did the x squared cancel out the bottom?
So there's one x here, and there's an x squared there. So one of the x's canceled, but that means there's still an x there. If you want to write them out, like x times x and then x over here, one of these x is going to cancel. I'm left with 1. If that helps you, then do it. Okay? Don't let the exponents get you. All right, you do that last one. So number 9, let's do and see how well you can do it on your own. x squared minus 14x plus 49.
X minus 7, X minus 7.
Good. X minus 7, X minus 7. Bottom left, x squared minus 49. How do I factor that?
X plus 7, X minus 7.
Good. Top right, can that factor? Good.
You can't do anything.
Bottom right,
And then 3 times X minus 7.
perfect. All right, now comes the canceling, right? So on the left-hand side, I can cancel the x minus 7s. On the right-hand side, top to bottom, I can't cancel anything. But then top left, bottom right, I can cancel out the x minus 7. Top right, bottom left, I can cancel out the x plus 7. The only thing left in my whole fraction is the 3 that's at the bottom. So this would be 1 over 3.
Wait, when you're dividing, you can cancel out, like, when they're on top of each other, but when you're multiplying, you can't?
No, you can cancel top and bottom no matter what. You can't cancel left to right. Like I can't cancel something over here with something here. You can't go left to right.
Okay.
But you can go top to bottom. The only difference between the multiplying and the dividing is the dividing you have to do keep, change, flip first before you start canceling.
If the X
Okay,
minus
thank you.
7, if the X minus 7 is being multiplied by 3, can't you not cancel it out? If it's,
Because you're multiplying, you can. If it was 3x plus 7 here, and I had something like x plus 7 in the top, I can't cancel part of it like that. But if I can take something out of it, those are two separate expressions, right?
oh, okay.
Does that make sense?
Mhm.
Okay, perfect. All right, you guys, go to WebAssign and get today's assignment open, okay? I think there's 33, 4, 5, 6, 7, 8. There's 6 problems total, okay? Remember the fraction shortcuts, like if you use the little dash, it helps you with the fraction, or you can just simply click on the little fraction thing. So if you go to today's class and you click go, here's your assignment for the weekend, okay? Notice it's got 6 problems, so you could probably just take your screenshot normal. You don't have to like scroll or split the screen to get your results. These are gonna be entered again using the fraction bar, or you can use your little equation editor, okay? If there's more than one parentheses, make sure you're using parentheses. The order won't matter as long as the right signs are with the right ones, okay? I'll give you, you've got like 4 minutes to get a little bit of a head start on it, unless you've got any other questions you want me to go back over. Okay, I'm just gonna go over real quick a couple of the really commonly missed questions on your test. So this was one of them. Let's see if I can zoom out on it a little bit. Okay, it said to simplify negative 32 to the negative 4/5. So the negative in the exponent, remember, pushes it to the bottom. This would become 1 over negative 32 to the positive 4/5. And that becomes the 5th root of negative 32 raised to the 4th. So 32 is 2 and 16, 2 and 8, 2 and 4, 2 and 2. That's exactly 5 2s, which means the 5th root of negative 32 is actually negative 2. But when I raise it to the 4th power, 2 times 2 times 2 times 2 is back to a positive 16. So that was just one version of the question. The other question would have stayed negative because it was an odd number. Okay, but that one was missed a lot. This one was missed a lot. 3x to the 3rd xy squared plus 2xy squared negative x to the 3rd. This one was missed a lot. Okay, so I have to cube this one, which makes it 27x to the 3rd. Distribute the square on this one, which makes it x squared y squared. Plus square this one, so it's 4x squared y squared. Cube this, so it's negative x to the 3rd. When I multiply, I add the exponent, so this becomes 27x to the 5th y to the 2nd. Negative here makes this minus 4. X to the 2nd and x to the 3rd makes that x to the 5th and y to the 2nd. Now the exponents are the same, so I can actually combine these into one term, making it 25x to the 5th y to the 2nd. That one was a big common mistake. Okay. That was pretty good. This one, when you factor, I think the mistakes made here were pretty much the order. When you factor that, it's 4 plus c squared, 4 minus c squared, and then the 4 plus c squared stays, but this becomes 2 minus c, 2 plus c. So I think the mistakes made on that, if I remember correctly, were just the order. Just be careful there. That one was good. Factor completely here. Was 2x plus xy plus 2z plus yz. Factor by grouping. Take out the x. Take out the z. And then the 2 plus y and the x plus z went together. Okay, I'm going to stop here and I'll continue, so I'll answer some questions. I'm going to wait to hear because a lot of these were great. Okay, a lot of you did really well. But something like that I want to go back over, which was like the first one. And this one, that was your cube factoring. Most of it was really, really good.
Monica Rango or
What I'll do is wait to hear back from the other Algebra 2 teachers, and then I'll release the feedback so you can see what you got right, what you got wrong, that kind of stuff. Hopefully I'll do that before the weekend. If not, I'll do it on Monday when they give me the all clear. All right, folks, have a great weekend. I will see you Monday. Don't forget to do your homework. Bye.